Hi everyone. You have seen in previous videos how we created some workflows with the state graph, but it is still heavy controlled with edges and conditions. What about if you want the model now to have a bit of more control? I'm sure you have heard about more about the agents and so on, and you want to do something around that. So in this video, we are getting straight into something super useful when building AI agents or to build AI agents. Here I'm talking about tools, I'm talking about binding tools, and something called a class called ToolNode. If you have ever wondered or if you have ever thought about how to get the language model to actually do things like call a function, hit an API, run an object detection model, or run another algorithm, or run another machine learning with it, this is where it all starts. I will show you how to define a tool, how to bind it to a model so it knows when to use it, and how tool nodes help in wiring everything together in the workflow. So from now on, or within this video, let's build it step by step and see it in action. But before starting, just one single note in here. In this exercise, just for the purpose of consistency, compared to what we have seen in the previous videos, I will still utilize state graphs. However, with React Graph, the same functionalities or the same type of functionalities can be built. So bind tools is a function that is used to let the model know what tools it can use. You can see in this example from the documentation that there was a multiplication function that was attached or binded with the LLM. And with this approach, the LLM can start utilizing the multiply function. You can think about many other functions yourselves and tools that you want the model to be able to run and utilize. If you are using LangChain OpenAI and you want to utilize bind tools or you want to include some tools, you basically load the model and then connect it or bind using llm.bind tools, and within that there is a list of tools. The other approach is more flexible. If you are after using, for example, other types of models, you basically utilize LangChain.chat models and do the same thing. If you are after using a function within the large language model or with bind tools, you need to give it what we call, or you need to decorate the function using the decorator design pattern. All you need to do is basically add the at before the function at tool. Let's look at the popular example, which is using the multiply function with the large language model or binding the multiply function with large language model. You can see here in the following example, importing the decorator from LangChain underscore core, then adding the function to bind underscore tools. You might be asking yourself now, what is the design pattern, or what is the decorator design pattern? So it is basically a design pattern in Python that changes the behavior of the function without changing the source code. Let's stop talking about LangGraph and LangChains a bit and jump back to talking about design patterns. Let's have a look at the following. I have the multiply function as it is. Then I've created a tool, a function called tool, that takes a function as an argument. Within it, I had the wrapper where I've added my code or additional code to change the behavior of the multiply function without actually changing the source code of the multiply function. You can see now that I've printed something before, printed something after, and then within that, in the middle, the function multiply was executed. This is the same concept with LangChain underscore core dot tools, the tool decorator, but the code in there, the code that changed the behavior of the function, makes it suitable to be used by the LLM. That is it, as simple as that. Another useful functionality which is pre-built in LangGraph is ToolNode. So the ToolNode is a pre-built functionality within LangGraph that allows running the tools called in the last AI message. This is the formal definition of the ToolNode from the LangChain documentation. However, what does it do? Basically, it looks at the last AI message and checks if there is a tool call, and then it invokes that tool and appends the results to the messages. But how does it actually know what tool to call? That basically happens with tool calls. Tool calls is a parameter in the AI message that allows to show the tool calls associated with that message. Here is an example of values within the tool calls parameter within an AI message. I always refer to the LangChain documentation because I really believe it's super rich. So having a look in here at this diagram, you can see that there is a loop, and within this loop, if there is still loop tool calls present within the application, keep calling the tools and executing them. And another note in here is that you can see every response with each tool is going to be wrapped as a tool message. All of this together helps us in managing the conversation or checking what's happening later on with the conversation if we go on and check the messages, or if we add to the state the messages. You might be already aware about the add conditional edges functionality, which is a function in LangGraph that allows you to decide to which node to go next. Within LangGraph, there is also a pre-built functionality that allows you to utilize the add conditional edges, but for the tools. And this function is called tools_condition. So what it does is that you embed it or you add it with the add conditional edges. And that allows to go from a node towards calling the tool node or the list of tools that you have. So in summary, it is a functionality that allows to route to the tool node if the last message has some tool calls. And if there is none, what will happen is that the next step is going to be towards the end node. As in the previous videos, talking about the overview first, then jumping into the code, let's delve into the code now. We will talk about the tool node, tool decorator, tools conditions. First, importing the decorator. Then I will jump in and get chat OpenAI, followed by the messages, which will be used with chat OpenAI. Now getting state graph and the start and the end nodes. Then getting add messages, which is a component that you will see how useful it is. Typing the specific functionalities annotated and typed dictionary. Going to utilize in here the tools, conditions, and tool node, and loading the API key into the environment via load.env. Now starting with the popular example, the multiply takes two integers as input, returns an integer as an output. Make sure to put the documentation for each function when using the tool decorator, and starting with getting the LLM to be able to invoke it. Here I got the ChatGPT 4 and the temperature I set it to 0. As we said, bind tools, then just specifying multiply in here. Then starting with creating the class that will be able to save the messages. This will be the app state, and takes messages, and you can see here this specific code that allows adding messages while interacting with the LLM. I always found that using such a tool with add messages is really helpful and valuable within agentic workflows or with conversational applications. Now let's go and talk about calling or utilizing creating the assistant node. Here is the call model function, and it takes the state as an input and returns the app state as an output. Invoking the LLM with the messages and then returning the response back. Initializing the state graph using the state graph class. Then creating the assistant node or making the function call model as the assistant node as in the following figure. Now adding the tools node. So workflow.add node, and then you can see we use the class tool node and include a list of the tools. I'll quickly add the edges in here. I'll start by adding the edge from the start node to the assistant, then followed by the conditional edge. So it either goes from the assistant to the tools to call one of the tools, or ends the flow. Final step, adding the last edge. Compiling the graph, then starting with an example. So the example is what is 5 times 3. Then creating the initial state by putting that value within the messages, ensuring like it's a variable, it's a human message with content. App.invoke with initial state given as input. After it runs, we want to print the messages. So saving the file and then running it. So you can see with the printed messages, what is 5 times 3, which is the user 1, then the output from the AI or from the tool message, then the return response back. Let's dig in a bit and check what's inside the messages. You can see here, if I try to get from the app state messages and then try to get the last one, it was an AI message in there, and it returned the last response. So checking the message and its details, let's check the tool underscore calls because it's an AI message. It's empty. There's no other tool calls. You can see that when I tried minus the second last, I had an issue with that. That's because it wasn't an AI message. Here you can see with the model selecting the function multiply to be executed. So within this exercise, you have seen certain or different kind of functions and classes that can be utilized when working with agents or building agentic workflows. We did revise or go over through tools, bind underscore tools, add messages. We also spoke a bit about the tool node class and conditional edges with tools conditions. Finally, we highlighted or we spoke about tool underscore calls within AI message. To show you the advanced applications or to give you a feel of the type of applications that can be done with agentic workflows or with agents, I decided to quickly implement an object detection tool that can be embedded and can be executed whenever the user asks for. I've used basically the YOLO model, which is very popular for object detection, in order to do the task. So what I've done is that I've introduced additional tool, which is detect vehicles or detect vehicle, and then added another node, which is store vehicle. And basically what does this do is saving the details of the detected object. You can see here that I've also added an edge from the tools to store the vehicle details. And because for the purpose of the exercise, what I've done is that I'm running that locally. So this is the image of the car. And then once you run it, you will see that the model, because the question has been, please detect the vehicle in this file. And you can see how the model or how the agent returned for us the details about the detected vehicle in the image. So let me show you the example just quickly. I've done the visualization to visualize the detection, and you can see that's what happened with the new generated image. This is some examples of what can be done with this kind of application, and I will leave it with you to think about possible type of applications that you might want to implement or utilize LangChain and LangGraph within.